Hey, what's up, everybody? Welcome back to another 3D Hangouts. I'm Noe, a designer here at Adafruit. Joining me every week, my brother Pedro. What's up, man?
What's going on, everybody? I'm Pedro Ruiz, the creative tech here at Adafruit. And every week we come to share 3D printing projects featuring electronics from Adafruit.
Oh yeah, this is where we combine 3D printing, DIY electronics, combine them together to inspire you folks at home. Pedro, what's on the show today?
Well, we are embedding electronics into 3D printed items this week.
Very
Big
special
deal.
stuff. Yeah, very special stuff. Let's go ahead and start it off with...
That's right. Every week we have a lovely assortment of segments. We started off with today's coupon code.
Oh yeah, today's coupon code is day off in celebration of summer. Take a day off and enjoy yourselves, folks. You need to recharge. It's summer. What a better time now to take a day off.
That's right.
Bueller.
During checkout, use discount code DAYOFF to get 10% off your entire purchase. And remember that orders over $200 get free UPS shipping.
All right, let's start off with the segments. This is what we do on the show, folks. Start off with prototype.
That's right. When we take a look at some of the behind the scenes for future episodes.
Oh yeah. We'll jump out and into our layer by layer. It's back, folks, layer by layer.
That's right. It's when we take a look at some of the CAD techniques that we use to create the projects.
And cat techniques.
CAD.
We'll do shop talk.
So when we talk about some of the ongoings in the shop.
Oh yeah.
Pretty cool stuff going on.
Very cool stuff going on. And then Q&A. We're going to answer your folks' YouTube questions.
That's right. Every week you guys have a bunch of questions. Go ahead and leave any of those in any of the videos below, and we'll eventually get to those.
Oh yeah. So let's start it off, folks. What are you prototyping? This is it this week. Always upside down. I can't not be upside down.
Yeah. So this week we are printing electronics inside of our parts. So
oh my goodness, it's finally here, folks.
Yeah. So this is a 3D printed battery tester.
Is it dual extruded?
It's dual extruded. It has the conductive filament on the inside, and when you squeeze the little two pads together, you can see that you can close the circuit and power up this cool little LED. Not only that, it also works with the bare conductive paint, so you can have something like the SMD little sequin NeoPixel on there and sort of do the same thing. Have an ultra slim little profile.
Man, that is awesome.
Look how bright that goes through. The resistance on this is pretty low.
All right.
And yeah, a lot of moving pieces that had to sort of come together to
all the planets had aligned for us to make this project, folks. But let's talk a little bit about this PLA. Who is this from?
Yeah, so this is from the guys over at Proto-plant.
Proto-plant, makers of Proto-pasta. They had a Kickstarter. They were successfully funded, and they have shipped to all their backers. Now we're working on getting some in the shop, folks. So very soon you'll be able to pick up some conductive filament and do some cool projects. Pedro, everybody wants to know, how conductive is this filament? Yeah,
so where are the notes on this? Yeah, so this is when printed in perpendicular layers, and through the Z layers, you have a difference of about 85 ohms. So that works out to being about, what is it? The resistivity is about 15 ohms per centimeter, which is at 1 centimeter by 1 centimeter cube of material. And it changes depending on the features. Okay,
so something like where the Z layers are going to be a little bit more resistive than the ones that are sort of layered out perpendicular. Okay.
Yeah, so what that means is the further away that it goes, the higher you get. So the resistance down at this pad is about 2.1 ohms, and then up here it's about 0.5. So the closer you are, the less resistance you're going to get.
Plenty enough for one LED. Did you try telling more? Maybe a series
so
of
I actually
LEDs?
hooked up about 3 of them on there, which is just holding it with my hand, and it was able to power 3 separate LEDs.
So not just traces, but what else do you think it's good for?
Yeah, so on their site they say that this is really good for capacitive touch
so
projects.
cool
And we did test that out. We'll show that off next week.
Okay.
And then things with little low power projects with Arduino. So that is definitely...
You can power an Arduino.
Yeah, so instead of having this, having the bare paint sort of, make the connections between this, it looks like you can actually just make a little slot, a 3D printed slot, and sort of just snap it in, where all the traces will be.
And this doesn't have to be flat. It could be on the Z, so you can have things like on the wall and all sorts of cool stuff.
Yeah, so that's some of the techniques we're trying to develop now, how to actually do circuits that are along and up a wall of an enclosure.
So this is
looking at next.
This is dual extruded. How well does it stick to? Did you have any troubles when printing dual extruded?
No, so we're printing this at 230 C, and we're printing at 90 millimeters a second, so pretty fast, and it's sticking to a lot of the materials that we're testing it out with.
Wow.
Things we're going to test out next is seeing how well it bonds to things like NinjaFlex, so we can make flexible sort of projects.
Yeah, with flexible joints. Okay,
Yeah.
that's a really cool idea. Now, how about the actual print quality? Is there any sort of things they gotta know? Like, how good is the layer adhesion?
The layer adhesion is really good. I'm thinking it's because of how hot we're printing, but obviously if you print lower, it's not going to stick as well.
Okay. Now, it's probably brittle, isn't it? Isn't it like PLA? Or?
No, so this is actually more flexible than PLA, than standard PLA. So it does offer a lot of flex, which you can see when we're doing all the bending on the tweezer here. So yeah, once you look at it just plain, it is very flexible.
That's crazy. Okay, so it's a little bit flexible than PLA. So what's it made out of, right? So what is this stuff?
Yeah, so this is made from regular PLA with a dispersant and a conductive black carbon. So it's a little bit more flexible than PLA.
So some particles in there that are conductive.
Yeah.
Mix it together, and here we go.
Yep.
Pretty cool. All right, folks. So we're gonna be doing some more projects with this. Are you gonna make a video? Are we gonna do a video?
We have a video that's launching next week. We just finished shooting yesterday, so definitely be on the lookout for that. And it's just a simple overview of creating the cool little tweezer.
Awesome.
Actually, if we go ahead and jump into our layer by layer, we can actually see some of the CAD techniques that we had to do to set that up.
That's what we're prototyping. We're gonna go ahead and jump into our layer by layer in just a second here. Okay, so, here it is. That's what we want to do. We want to look at CAD, right? So you're gonna take a look at the CAD? Okay. And then we'll take a look at slicing, huh? All right, cool. So this is the part in Fusion Fusion 360.
Yeah, actually, to start this off, the outlines were actually created inside of Photoshop.
Oh, I'm sorry. All right, let's jump into Photoshop and take a look here.
So you can see the outlines that I created for making the tweezer here.
Okay.
And that's a simple little, little standard tweezer. And inside there, I built all the little trace that's going to go through the middle of that.
Okay, cool.
Probably could have built this a little bit better. You could have just had one path and increased the stroke around it, and then outlined the stroke inside of Illustrator. It's probably going to be a better way to do this.
Okay.
Because this, as you can see here, it's not all completely
even. Okay.
Even, yeah.
It looks pretty good though. So you have to be aware of where you cut the trace. So I'm thinking this is where the LEDs connect to.
Yeah, so once we export an SVG of these inside of Fusion 360, we'll just extrude these out and then start doing our cool little fillets to make it more comfortable in the hand.
Okay, what kind of special stuff do you need to do in order to sort of make the two parts work?
Yeah, so what you have to do is use the traces to actually cut out of the main body so that they don't overlap when they're printing with so each dual head does not print on top of it. Which is one of the mistakes I did when I was first starting to do this. The infill was actually, cutting the traces.
They're intersecting, huh?
Yeah, so they're intersecting. So if you just delete the body on that, you can see the trace there.
I'm trying to make this transparent so we can see it. It's just running a little slow because Cam Twist is running too, so it's trying to.
Yeah, so here we can see the inside of the main body here, and you can see the traces on the inside. And if you cut that away too, you can see that this is actually the tools that we're using to subtract from the main body.
Is this where the LEDs go then?
Yeah, those are the slots channels where they go inside
Very cool. And then we'll bring
back. If it's any standard LED, like the big ones or the regular little smaller ones, the 4mm ones.
I like how you plan the distance between them. Work really well for the LED sequin.
Yeah, so I just measured that before
building
the traces for all of this.
Okay, so when you export them out, do you have 2 parts or 3 parts?
So you're going to have 3 parts. 2 of them, of course, are not connected, so those are going to be inside of one STL. Okay. So you just export those out and bring those into Simplify 3D. If we just jump into that.
Sure. Give me a sec here. Simplify 3D, folks. Here we go.
Okay, so inside of Simplify 3D, we'll just select all 3 objects, import those inside here. As you can see, we'll have to center these so that they have one origin. So we'll just go up into Edit and Align Selected Models. Okay. And then it'll just combine all the origins together. Yeah. Next, we'll have to actually make a group out of this, and don't forget to do that because otherwise they're not going to move all of them together. Okay. So select all these and hit Command G or Command or Control G.
Or it's in the File menu or Edit menu. Okay.
Yeah, to turn that into a group, and then from there we can use a nifty little command inside here, the Place on Bed, and it'll just let you select one of the triangles, so it'll make that go onto the bed. Okay. Yeah.
Cool.
We'll just simply center and arrange that in the middle there. And then after that, we can just jump into our dual extrusion wizard. I didn't jump into that one because I already set it up. And essentially what it lets you do is just select what tool head each model is going to print on.
Okay, cool.
So the thing you got to
parts.
remember is that color 1 is going to be the right extruder and color 2 is going to be the left extruder. So you just got to figure out where you're going to want to print that. In our case, the left extruder, because it's closer to the blower fan, and it's going to print a lot more of the body than it is the traces.
Okay.
I'm going to make sure that that we accordingly adjust that.
So strategic planning here, folks. Think about where it's going to go, how it's going to cool down, and that. Okay, so let's keep going here.
Yeah, so for color 1, we're going to select the PLA, which is going to be the tweezer.
Okay.
That's going to print the
Outer
main body.
shell.
Yeah, the outer shell of the whole thing. And then inside of color 2, which is the left extruder, I'm going to make sure that the other objects are selected.
Okay.
And other notable changes that we made were inside of the additions, we'll make sure that the ooze shield is selected. And the default here is 10 millimeters, and
No,
that was
3.
just a little bit, or 3 millimeters. That was just a little bit too close to the model, so we increased it up to 10.
Okay.
The ooze shield outline, the default is 1, and we want to have an extra one just to be able to catch any other little oozing that's on the other extruder, and that's really going to help give you a cleaner model.
Okay. How about temperature?
The temperature, because of the blower fan, is actually going to cool down some of the nozzles, and we're going to want to run that like at 100%. We're going to increase it to 230 degrees, just to make sure we're compensating for the cool down from the blower fan. And the print speed for this, now we're printing at 80.
Stop doing.
The 80 default speed for that, and then 120 for the X and Y travel. And then those are basically the settings that we use for that. And when we build out our tool here, we just deselect the ones that we're not using.
Okay.
We jump inside there. Just a little
bug there.
here.
Okie dokie.
And we can see if we change the coloring to the active tool head, we'll be able to see all of the layers being laid down on top of each other. So here we see the green is going to be the PLA, and the blue is going to be the conductive filament. So you can see how it lays down the PLA first, and then right on top of that, it's drawing the traces inside there.
This is what you want to see, folks. If you see that the layers are starting to stagnate on top of each other and they're like intersecting, something's wrong. Like that's the first cue. So they have to be separate. Is there anything else that you want to note?
This took about an hour and a half to print, and you definitely just want to check on the print and make sure that everything, nothing's lifting or anything like that. And this should print pretty good.
Okay, so the ooze shield. Do you want to take a look at the ooze shield over the overhead, or is that okay?
Yeah. So this is what the ooze shield looks like. So when it's printed, here's the outline of it like that, and what it's doing, because both heads are turned on, it's sort of going like that and sort of depositing a lot of the little mess on the shield instead of doing it on the main body. And this looks a little bit more messier than it is because it is transparent. So here's probably a better representation of that.
Okay, cool.
So it does look a little bit more cleaner than it would than if it didn't have the ooze shield on there.
Yeah.
So definitely a good option to turn on when printing in dual. You're doing dual extrusion prints.
Cool. All right, folks. We'll be doing some more testing and more experimenting with this.
The upcoming stuff that we're going to do is trying it out with flexible materials, see if we can make some flexible circuits.
Yeah, maybe even some metal stuff too.
Yeah.
See how well that works. Okay, well, very, very cool. Let's take a look now at the next segment. That was, of course, our layer by layer segment. Talked a little bit about the CAD and the extruders, dual extruded profiles. Okay, next up, we're going to take a look at shop talk. Somebody asked me on Twitter, why would we go with the FlashForge Creator Pro versus the Flash Creator Dreamer?
Yeah, so they're built by the same company, but they are a different build. So I did take a lot of things in consideration when looking at which ones actually carry, things on the surface like the Wi-Fi, color screen, filament sensor sound, great.
They sound great. Yeah, it sounds like an upgrade from the Creator Pro.
Yeah. But actually, when you're looking real into it, like the enclosure is all plastic, so it's not as rigid. So I'm, questioning whether it can how good it's going to operate at high speeds. And we kind of want to print fast since a lot of these projects take so long to produce.
Yeah.
And another thing is the color screen in the Google search when the autocomplete kept coming up with, how to fix a color screen. So it looks like,
it's a great way to find out what's a common problem, is just to have Google auto-complete it for you.
Yeah, so it looks like the touch screen might have some problem. And then the filament sensor, we had a clog over the weekend, and as you can see in this video, the sensor gets away of both extruders. So when you want to change a clog, you have to literally
dismantle the whole thing.
And if you skip forward a little bit, this isn't a simple little process. It is quite a lot of things.
This is extensive, folks.
Yeah.
You have to. There's a lot of screws, a lot of wires you have to take apart, and it sounds. This is just to sense the filament. Like if you have a clog or jam, you kind of don't need a sensor. You kind of can tell when it's not printing. Mm-hmm. So
of course, this is like if you're away or something like that.
But then when you do have a clog, it's kind of if it's 12 in the night or 12 in the morning and you want to kick a print off, but you have a clog, you can't do it in 5 minutes. It's going to take you like a half hour.
Yeah, so remember, again, this is for the Dreamer Flash Forge. This is not for the Creative Pro. The Creative Pro is a lot more easy if you switch over to the footage that we shot of our clog.
So we're not done yet. There's still like some steps. You still have to take this part off.
Yeah, this would
be a nightmare. We're going to get to it, folks. Here we go. We're getting there. All right, so here's our first clog.
And that's pretty much...
And then you still have to take that part apart.
That's all you had to do. You had to do all that work just to
yank
release
it out.
That. Yeah.
And over here, you have to take apart sort of the thing. And then these are just all the parts that are there. So top cover, PCB, the heating block. Okay, well, we had our first, Pedro, help me, clog. Didn't we have a first clog here?
Yeah, so this was just like four different screws that we had to remove, and we're inside the guts like pretty quick. As opposed to having to take off a whole bunch of extruders, having to take off a whole other motor just to get to this tiny little little clog that's
the most
stopping
common
everything.
Way that clogs, right?
It's definitely not an if, it's definitely a when this will happen to you. And when it does, you don't want to have to dismantle an entire second motor just to get to the other motor. So this was very easy to get to, like about 10 minutes, and
back up and running in 10 minutes, folks.
Yeah,
that's what we like.
These are all the little parts that came off of just that one motor, and as you saw, it was the left motor as well, which is
gets cold the most.
Yeah.
Okay. Well, very cool. That's one of the reasons why we prefer the Creative Pro over the Dreamer.
Yeah. So it's build quality. It's the having all metal frame. Sailfish is still the same sailfish. The open source sailfish that everybody uses. The Dreamer sort of forks off and uses a different sort of firmware for that. The filament spools go on the inside, so you'd have to print like different spool holders to go on the outside. There's all these different little things that you don't think about.
Yeah. So we had some considerable time to sort of look at the two.
Yeah. So we were thinking first and foremost, operation-wise, ease of use, and of course, open source, what firmware it's using. So those are a lot of the factors that went into choosing the Creative Pro.
Okay. Well, it's coming in. We're stocking them very soon, so folks be on the lookout for that. You'll be the first ones to know, of course. And that is our segment here. Good job. This was our shop talk. If you guys have any questions about what we talked about, or you have any concerns, let us know. We're going to jump in now to our Q&A section. This is where we answer your questions from YouTube. This is our first one. This one's from Rasmus. Have you ever had an Ultimaker? Any experience with one? If so, how would you say it holds up compared to something like the Type A machine? When I was looking for a 3D printer before the Type A came out, the Ultimaker seemed to be the best bet in pretty much every way. Now that I have an Ultimaker 2, I'm still wondering how it actually holds up to other 3D printers. Would you get an Ultimaker original or 2 yourself? Cheers.
Okay, so we actually have Ultimaker 2s en route. I think we're getting them this week. They'll be in the shop pretty soon after. I think they're shipping at the same time.
This is something special, folks. We typically like to test our units before stocking them, but this one took over a year to negotiate a contract with. Tell me why, Pedro.
I don't know. They're pretty picky on
Picky
who
about
they...
their vendors, to be honest. They are very picky about their vendors. It took a little bit, but we chose the original, not the original, the 2.
The 2, yeah.
That's the only model that...
in terms of margins and price, it was the one that made the most sense for us.
Absolutely, yeah.
And yeah, we didn't have an opportunity to test it first because of how long it took to actually get it in there. And then all the reviews we've seen, like Makes, Shootout, I mean, it continuously won all of the awards. It always won best in quality. So we're definitely going to test it against the Type A machine.
Absolutely.
Its home is going to be right next to the Type A machine.
It's going to go right next to it. That's perfect.
Right off the bat, I can tell you that Ninja Flex works right out of the box with the Type A machine.
Okay, with Type A.
It uses 175. The LT maker uses 2 millimeter or 3 millimeter, 2.85, whatever.
It's precise, to be exact.
Yeah, so big differences there.
Bowden drive system, folks.
This is direct drive.
We've dealt with a Bowden on a Delta machine over there, and it's a little bit more touchy, right? Metal filaments tend to break.
Again, that's because it's 175. We don't know how the thicker filament's going to affect that.
Yeah.
On the Ultimaker.
It's supposed to be really, really fast, high quality, reliable. We're going to put it to the test, folks. We're going to try it all the projects and see how well it is against the Type A machine, and of course against all the other printers too. We'll see how well the build quality is.
Yeah, in terms of course, the bed size, I mean, this is 305 millimeters cubed, so it's definitely wins in the bed category. The new model does have a heated bed, so I think the Ultimaker has a heated bed as well. Yeah, the Type A
too, I think. Yeah.
Both glass.
Auto leveling?
I think they do the standard manual leveling,
Very
so
good.
wins points there for that. So we are definitely going to check that out. They should be in here sometime this week.
Yeah.
And
if we have any problems, we will definitely ask you, Remus. Okay, cool. Thank you for the question. Next up, this one's from Dan from Sean Union. What's up, dude? I've started trying to model my videos after yours. Less than 3 minutes. Parts list, some assembly shots, etc. Is there an actual Adafruit formula or guide for good videos and project descriptions? Are you ever surprised at a project that does well versus one that doesn't do so well? Keep up the great work. Thank you so much, Dan. Yeah, totally. If you started watching our videos, you can see that they're kind of the same, but a little bit different. They all have that same stuff. Like, again, under 3 minutes. Sometimes they're a little bit longer, but definitely parts list, assembly shots, all that's really good. One thing I would say, you definitely want to have within like 5 to 10 seconds, you want to show what the project is, what is it does, why do you want it.
Immediately want to show it working, and you want to show examples of it. You don't want to show like, you don't
want to show the build processes and then show it. We want to see it right up front. Is it worth watching your video? It's just like when you're writing an essay or a novel or something. You want to have that attention grabber in the first sort of paragraph. You really do. But you're already doing it. I'm subscribed to your channel. We're Pixel 3D on that YouTube channel, and if you see a like from that, that's us. You're already doing a really good job. I've been watching, and that's pretty much the only sort of tip I have. You're already doing it really well. Everything is written very simple, concise. Your pacing is really good as well. And it's funny because not many people really ask about a guide or things like that, but it turns out even Phil B would be interested in some tips on documenting, maybe some things to look at when you're photographing and doing just documenting, because that's a big part of our work. A lot of it is content creation, like half of it, the bulk of the work is there.
Creating a guide for doing good video production on it, it is something that's in the pipeline. It's just that I don't think a lot of people are really gonna, they haven't been asking for it. So.
You're the first person that's sort of asked, so that's really cool. You're already doing a great job. But as far as an actual video or guide, rather,
we'll make one eventually.
We'll probably make one eventually. Are we surprised when projects do well or don't do well? After 2 years of doing this, I think
we can tell you right away that anything that has a Raspberry Pi in it is going to get high views.
Yeah,
some of the things that don't get as many views is like some of the cosplay stuff.
Yeah,
so Mar had an idea to do some like devil horns, with some like little flaming devil horns, and that one didn't do so well. Even though it was around Halloween time when we released it, so it's just weird. It's depends on how many people are watching, and I guess. That was around the time when YouTube changed the way their view count works.
Really?
So
oh man, a lot of different factors.
It's always different factors.
Don't be afraid to try different things, try different formats. Just keep experimenting with it too. You'll see some videos are different. Sometimes we do some stop motion, sometimes we don't.
Moving on.
Okay.
Thanks for your question.
Yeah, thanks for the question.
Keep up the good work.
Keep up the good work. Okay, this one's for Kirby G. Can the 3D printed Adabot be revised at some time and maybe update with new modeling and printing techniques that you've learned? Also, how about other characters such as Cappy?
Yeah, so definitely now that we have all the artwork and some of the processes figured out for building all those characters.
We can do dual extrusion, we have conductive filament, we have flexible filament, a lot of different options here now.
Oh, yeah.
We definitely want to revisit this at some point. Really the chess set was sort of laying down the framework of figuring out how to print these models because there are kind of,
we have all of the source files now to create all of the
There you
artwork
go.
for it.
Yeah.
So yeah, can easily be done.
Great
Just got to
question,
get all
Kirby.
these other projects out of them.
Oh yeah, it'll take a little
pipeline.
bit, but hang in there. All right, thanks Kirby. Next one, this one's from Mark Reyes. Hey guys, I have a TAS 5 printer and I have to flash the onboard controller when printing NinjaFlex, and then I have to flash it again to print in PLA. Is there an easier way to do this? Can't the settings be set in the slicer? By the way, I'm using Simplify 3D.
Yes, they absolutely can, and you should check out Simplify's YouTube channel to figure out how to properly
swap between the two profiles?
Swap between the material profiles.
Yeah.
I
get confused
The only
too.
time I had to flash my firmware was when I added the dual extruder onto the TAS to do the flexible.
Is that really
other than that, I never had to flash it again. So yeah, it's definitely just change your material settings inside of Simplify 3D.
Yeah, it should be easy enough. It's just picking the profile.
Yeah.
But okay, cool. Well, that was it.
Yeah, I think the print speed for that was the same as all the other printers, about 30 millimeters a second. And I think you turn retraction off as well.
Another good resource is definitely their forums and their contact support forum. I think they're very responsive. They really want to help people out, and even on their Twitter or social channels, they'll also get at you there. So
yeah, check that out.
A lot of places to check out. All right. Well, thank you, Mark. Next one. This is going to be our last question. This one's from Chris Young. As you saw from last night's show and tell, this was a couple weeks ago. I'm just getting started with my new PrinterBot Metal Plus. I'm controlling it directly from my PC using the USB connector and Cura software. The getting started .ini file that I loaded from PrinterBot has been running at 45 millimeters a second and a temperature of 210 for PLA. I'm getting good results, but most of your tutorials on the learning system suggest a speed of 90 millimeters a second. I've read somewhere that the faster you go, you should increase the temperature, but do you also need to increase the speed of the filament feeding? I don't see any options for that in Cura. Your recommended temperatures of 230, is that the only change I would need to make for faster speeds? Good question.
So
Let me
go
load
ahead
up
and jump
Cura.
inside of Cura. We can show you where the settings is for that.
Sure, just give me a second, folks. Go to screen cap, here we are.
Okay, so inside of Cura, the thing you have to go into is expert
Well, first of all,
mode.
yeah, so this is probably what you see quick print. You don't get many there. When you switch over to full settings mode, this is where you want to look at here.
Okay, so this is where the print speed is at. So I don't recommend going 90 on a printer bot. First of all, the sound is gonna make it sound like it's gonna explode. And because of the tool head and how big things are on the extruder mount there, it's might not be happy printing small little intricate things. But if you're printing like industrial type things, like
Big parts.
big
Big
parts, like I don't know, like automotive parts or whatever,
Brackets,
things like that, it'll work pretty.
Spool holder.
Yeah, it'll work really good at 90.
Yeah, because it's a simple sort of big part.
Yeah, more complex shapes, I'd stay around 60, 50
Right on.
for that.
Okay.
And the spot where that is inside of advanced.
Here's your travel speed, right? And it tells you right there, that's the speed at which the head's moving. So it's
Yeah.
at 150 right now. But we can totally change that to somewhere. You really want to have sort of a faster travel speed than flow rate, typically, right? So when you go when you go to 45, you have like 60 on the travel. So yeah. What about the talk about
The temperature, yeah. So we always print out 230 because of the differences in the extruder. It seemed that it needed to print at 230 sometimes, and as we're seeing now with the blower fan,
it's cooling it down.
it cools the nozzle down as well.
Yeah,
So we have to
that's-
compensate for that. So
yeah.
that's why we raise it up a little bit higher.
Okay. But would you agree that when you go faster, you want to print a little bit hotter so that the flow is, is a little bit more?
Yeah. But again, it's based on the model too. Some models will print okay fast. Some you absolutely have to print at a slower speed. So
Totally.
it's just it's based on the model.
Now I think Chris Young you were printing the Adabot, like his feet. When you're doing support, definitely want to print at like 40 millimeters a second, so that the speed of the head doesn't knock off your support material. 'Cause it's kind of a thin sort of thing, right? It's in support, so.
And I think
another reason.
Yeah, the multiplier for that when it's doing support material, I think it prints a little bit faster too, so that it doesn't stick to the main model. So Yeah, just go a little bit slower. I think 50 should be a good speed, and 230. I mean, it's just going to ensure that you have really good layer bonding.
Okay.
If you go higher
Okay,
temperature.
well, I hope that answers your question, Chris Young. Thank you for asking. And we're just going to jump out of our segment thing. That was, of course, Q&A.
Remember, if you
Q&A.
have any questions, leave them in any of the videos, and we'll eventually see those bubble up, and we'll answer them in a future video.
All right, all right, folks. So I think that's going to be it for the show. One last thing. How about that coupon code?
Yeah. Don't forget, if you want to pick up any of the materials that, if you want to start messing around with conductive filament, or want to get into dual printing, we will have those in the shop very soon. Of course, you can get 10% off every Wednesday and Thursday. Just look out for the discount codes. This week, it's day off. Just use that during checkout to get 10% off. And of course, any order over $200 gets free shipping.
Okay, well, that's going to be it for the show, folks. We want to lift you off with some couple links. Of course, this week's project was the 7-inch display. You've seen us talk about it last week and a couple other weeks. That's up now on learn.adafruit.com. There's also a cool video on YouTube. Definitely hang out with us on Google+. There's a lot of posts there. Every Thursday is 3D Thursday. Got all the stuff for you on the blog. And how about the Instagram? We've been really pushing out some new photos. Definitely encourage you guys to check us out on Instagram. I'm at Ekin.
I'm at Video Pixel. Definitely check it out if you want to see any of the behind the scenes for future episodes.
Oh, yeah. Next week, Wearable Electronics is back with Becky Stern. She's got some really cool projects for you folks. Project Workshop, Q&A, every Wednesday at 2 p.m. So be sure to tune into that. And then shortly after, at around 7:30 p.m. Eastern Time, we have Show and Tell. That's where you can come in, share your projects, your maker spaces, your retro gear, tools, all sorts of cool stuff. Hang out with us and Len Lamar and talk about your projects. Yeah.
Everybody always talks about, is there a 3D printing show? Where can I show off my 3D prints? Come
right
on.
Here, yeah, come on here. We invite you. You need us. Meet you. All right, and then after that, we got a full hour of Labar and Phil on Ask an Engineer, Arduino, open source news, all of the happenings. Maker business, manufacturing, and Raspberry Pi, all that and more. Hour long, like I said, every Wednesday night, 8 p.m. Eastern Time, folks. Well, that's going to be it for the show. And I want to thank you guys again for sponsoring our show. We make this possible because of you. Pedro.
We're here every week. Don't forget, check out all of our projects. Learn.adafruit.com if you have any. Definitely, Halloween's coming up, so you want to get inspired. Just look through there. There's always a ton of projects on there.
Check out the playlists too on YouTube.
That too.
All right, folks. So we're gonna get out of here, and until then, be sure to keep on making.
See you guys.
I'll see you guys next week. Thanks for watching.